what I'm going to do is I'm going to enter the function as is without using the list, which is more convenient, but I'm going to enter the function as is just to check and find my error. So in y equals, I clear. So this is negative 0.02 x to the fourth, and then a plus 0.28 x to the third, and then minus 0.3 x squared, and then plus 20. Okay, so now I go to second and table, and I will enter my numbers. So 33 divided by 8, and then 51 divided by 8, and then 69 divided by 8, and 87 divided by 8. Okay, finally I'm going to copy these numbers. So that's my page 3. So the area with the midpoint 4 will be 9/4 in front, and I'm copying 28.758 plus 47.318 plus 66.657 and plus 64.9 plus 904. Okay, so very nice, I forgot to share. I just realized that. Okay, so what I did, I entered the function in y equals, my apologies, and then second and table, and I got these numbers. I plugged in the 4 numbers that we need. The last one is from a remainder from a different problem. So I copied and I added up these numbers. So now I stop sharing, and these are my numbers. So in parentheses in front, 9 divided by 4, open another parenthesis, and I add these. So 28.758 plus 47.318 plus 66.657 plus 64.904. Close and close. And this is 467.18. So somehow I had an error in maybe entering the lists or something. So this has to be corrected as 461.392. And look at this. This is the exact, and this is what we got with the midpoint. With the midpoint, we didn't use any integration here, right? So with the midpoint 4, we got this, and with the midpoint, with the integral, we got this. That is perfect. Okay, my apologies for that. Everything was fine here, but when I entered it in the calculator, something went wrong. Very good question, Amanda. Thank you for asking this. I'm ready for your next question before I continue. Anything else? Amanda, is this better now?
Yeah, sorry. It was actually only that first part of how to get the interval, the base. I was missing that in my notes, so I wasn't sure. I just didn't remember how to get the base. So sorry you had to go through the whole thing.
Oh, no, that's fine. When I write the solutions, now I can copy it directly. Very good. Anything else that you encountered? Other questions? Anything else? Okay, so first I wanted to go back to y integration. Why? So, and I want to answer this question with a problem from your book. So, for example, you can choose a word problem that I selected for homework if you'd like. Or I will choose 28 on page 389. I don't remember if I chose this for the homework. You'll let me know. So we are given the total, we are given the marginal cost, and we know that the marginal cost, is the derivative, and the derivative is given to us. C prime of x equals 1 over 6 x squared minus 20x plus 1800. And they're asking us to find, it says, Manganiello Paving Incorporated has found that the marginal cost in dollars of paving a road surface with asphalt is given by this function. And they say for x less than or equal to 80. Fine. Approximate the total cost of producing 270 pints of juice using 3 subintervals over the interval 0 to 270. So basically what they're asking us to do is look at the interval 0 to 270. This is a quadratic function with a positive leading coefficient, so it has a minimum. So let's say,
I think it's 0 to 40 for this one. I think 27 was 270, sorry.
Oh yes, I copied the wrong problem. I do that all the time. Thank you very much. So I copied the function from one and the interval from the other. I'm very good at that. Thank you so much. Thank you. My apologies. Very good. So the function has a minimum. So we are really asked to find this area. The question is why? And the answer is, if I find this area, I will find the integral between 0 and 40 from c prime of x dx. And what will this mean is the antiderivative of c prime is c of x evaluated from 0 to 40. So when we're asked to find this area, we are really asked to find the function whose derivative is that and evaluate it from 0 to 40. Knowing that we're not going to, there is no need now, since we already know the fundamental theorem of calculus and we know how to calculate this, there is no need to split up this in 4 subintervals and determine the area under, so this is c prime of x. So when we determine this area, we are really determining the antiderivative of function c prime, and we evaluate from 0 to 40. And this will be the cost for producing 40 miles, what is it, 40 miles of paving 4,000 feet of road surface. 4,000, because this is 40 is in hundreds. 4,000 feet of road surface. So that's the connection between the area under a graph and the integral. They are the same thing. The integral is the area under the graph. Why would I want to determine the area under a function like this, under a derivative function? Is to find the cost, in this case, between 0 and 40, meaning the cost of producing exactly 4,000 feet of road surface. So that's why we use integration. That's why we calculate area under graphs to answer this kind of question. So there is no problem here because the integral from 0 to 40 from 1/6 x squared minus 20x plus 1800. Do not forget the x. This and this will always go together, and this is the function in the middle. So all I have to do now, find the antiderivative of this and plug in 40 and subtract when I plug in 0. But when I plug in 0, it's going to be 0. So let's identify or find, I think I'm on 4, yes I am. So let's determine the integral, the antiderivative of x squared. What is the antiderivative of x squared? Anyone?
X to the third over 3.
Excellent. minus 20, the antiderivative of x, or what function prime is x? We increase the power by 1 and we divide by that number. And plus 1800x from 0 to 40. Okay, so you understand that there is no need to plug in 0. Because when I plug in 0, everything will be 0. So I will only plug in 40. So this is 1 over 18 times 40 cubed. This is minus 10 times 40 squared plus 18,000. So here's my calculator. So I have 40 cubed divided by 18 minus 10 multiplied by 40 squared plus 1800. Oh, of course, this new calculators, you have to be careful and bring down. So 40 to the third, you have to bring it down, divided by 18, and then minus 10 times 40 squared and plus 18,000. And press it.
Plus 18,000. Wouldn't it be plus 1,800 times 40?
Times 40, of course, yeah. Times 40, absolutely. So 1,800 times 40. Thank you very much. Okay, so I got 59555.55, and that's the cost. Any questions about this? Any questions? Anyone? Did we all get the same thing?
Yes.
Perfect. Okay. Any questions about integration and why we calculate areas? Any questions? Any questions? Okay. So I'd like to move on to page 401, and I would like you to choose if you would like, or I will choose first if you'd like. Exactly what we just did. Everything the same. So let's say, do we want to start with number 12? More practice on how to determine areas.
I think that works.
Okay, you choose the next if you would like. So 2 over x, this is our function, and we are asked to find the area under the graph. Find the area under the given curve, such and such. So we know that the area now exact, we don't need any subintervals. The integral from 1 to 4 from 2 over x dx. So one property that I would like to mention here, or maybe we can mention several properties, but for this particular situation, the integral from a to b from f of x multiplied by a constant times f of x dx, is the same what we did with the limit. The constant goes in front as a factor, as long as it's multiplied. So this is the constant times the integral from a to b from f of x dx. This is what we did with limits, if you remember. The limit of a constant times a function as x approaches a is the constant times the limit of f of x as x approaches a. Same type of property. So when I start calculating that, I will have 2 the integral from 1 to 4 from 1 over x dx, because 2 over x is the same with twice 1 over x, and it makes my life easier. So I copy 2, but now I have to ask myself, what function prime is 1 over x? So which function prime is 1 over x? Anyone remembers that? Perfect, excellent, thank you very much, indeed. So then this is natural log x, and it has to be evaluated from 1 to 4. One comment here, we always have to have the absolute value. And you can say, but why? Because remember, natural log is defined on positive values only. In this particular case, the absolute value can be omitted. Why? Because we have from 1 to 4. But if I have from -3 to 4, it would have been a little bit of a problem because the function has to be continuous. But if I had between -5 and -3, I would have had to use the absolute value. Okay. So we continue, we didn't finish. That equals. We keep the 2 outside. And now we apply natural log, we plug in 4. There is no need for the absolute value, it's a positive number, minus natural log when we apply 1. When we replace x by 1. So what does this equal to? If you don't remember, just put in the calculator. That is 0. So this is 2 natural log 4. So one comment for the fundamental theorem of calculus. What am I talking about? What we looked at last time. The integral from a to b from f of x dx. This is what we just used here. Is the antiderivative evaluated from a to b. So, of course, and this is f of b minus f of a. Why am I writing this one more time? It's because I want to add here one very important item. F of x must be continuous on the interval a comma b. If it's not continuous, the fundamental theorem of calculus does not apply. We cannot calculate this. So it is absolutely mandatory that this function is continuous on the interval a comma b. Is defined everywhere, if you want, on the interval a comma b. If you prefer that, maybe that's even better. They must be defined. Continuous is stronger. So I personally prefer this. Because continuous means defined, for sure. Everywhere. So if the function is not defined between, so for example, if I use -3 to 4 from 1 over x dx, fundamental theorem of calculus does not apply. Why? Because x cannot be 0, and 0 is in the interval. So this function is not continuous on the interval -3, 4. So this cannot be calculated this way. So that's one comment. Okay, let's continue. Let's determine 36. If you want to choose, I'm more than happy to on 401. So they're giving us the graph. We just were asked to integrate from 0 to 2 from x squared minus x dx.